So in this instance, we have a D flip-flop. Only thing is that we have an enable and a reset. So for the clock to even work, enable has to be on. So in this case, the enable is the clock, which is 1, which is the positive edge clock. Q is still the value of D, and Q bar will be the opposite of Q, which is the next state value. So if I've created a truth table, and so if enable is on, then the clock is on, and we have a rising edge clock, which is 1. If D is 0, then Q is 0, and Q bar will be the opposite of Q, which is 1. If the rising clock edge is at 1 and D is 1 and Q is 1, which follows D, Q bar will be the opposite of Q, which is 0. And for our reset state, we're saying that reset is like a button to restart and input, to restart and take and force Q to be 0. And Q bar would be the opposite of Q. And so, for example, in my simulations, if the rising clock edge is at 1, D is at 0, if my clock edge is on, then enable is on, so that's 1. Q follows D, which is 0, and Q bar is the opposite of Q, which is 1. If I have D to be 1, my enable is on, so my clock is on, then Q follows D, which is 1, and my Q bar would be the opposite of Q, which is 0. And so for my reset, we only push a 1 if we want to force Q to be 0.